Hi, and welcome back to another episode of Science with Dr.CK. So I know it's been a while since you've seen me, but we are back and better than ever. And I'm so excited to share my new passion with you. So before I get into talking about that, I want to give you a little bit of background. And one of the things that hit me a few months ago was how sometimes life just comes full circle. So let's rewind back to 1996 when I was working on my PhD in chemistry, and I decided that I wanted to look at the element selenium. And for those of you guys that don't know, selenium is an essential trace mineral that our bodies need. Selenium is an essential element in the enzyme glutathione peroxidase. And the reason I was interested in glutathione peroxidase is because it's responsible for cell replication. And when you think about cancer, really and truly, if you look at cancer in layman's terms, it's unregulated cell growth. So the first thing I needed to do was to figure out a way that I was going to analyze for selenium. And so I went to the store and bought selenium supplement tablets. And I bought different brands and also different lot numbers from those brands. And I analyzed them to see how much selenium was actually in those tablets. And oh my gosh, I found out that they did not contain what they actually were supposed to. And not only did they not contain what they were supposed to, a majority of them had quite a bit less, about 50% less than what they were supposed to. So now fast forward almost 20 years later, and I have a new passion, and it is thanks to a company called V-tox. A girlfriend of mine introduced me to this company, and the reason I became interested was because they produce supplements that have a medical grade technology in them. And that leads me to today's episode and the main content. What is a liposome? Let's talk liposomes. So I decided to go out and see how many people actually knew what a liposome was. On the hunt to see if someone can answer my question for me. Let's see. Oh, here comes somebody right now. Let's check out and see. Hi, excuse me. Hi.
Hey,
Hi, how are you today?
I'm sick.
Oh my gosh, I'm so sorry to hear that.
Okay.
Can I ask you a question? Is that okay?
Yeah, what is it?
So I wanted you to take a look at this and tell me if you know what this is.
Mitochondria.
That is a amazing, really good guess, but it's actually not. It's a liposome.
Oh. Okay.
Hi, excuse me.
Hi.
How are you today?
Good. Good. How you doing?
I'm doing well. Do you mind if I ask you a question?
Sure.
Okay, I just would like you to take a look at this and tell me if you know what this is. Okay, that's all right. Thank you so much. Hi, excuse me. Do you mind? Can I ask you a question? Do you happen to know what this is?
Of course I do. It's a liposome.
So according to my results, 1 out of 3 people know what a liposome is. Well, let's look at the American Heritage Dictionary of the English Language, his definition. And you can see that it is pronounced either liposome or liposome. And according to this dictionary, it is a microscopic artificial vesicle consisting of an aqueous core enclosed in phospholipid molecules used to convey vaccines, drugs, or other substances to target tissues. Now, if we look at a dictionary on more of a biology level, it says that a liposome, or liposome, is an artificially constructed phospholipid vesicle, which can be used in various biological experiments. Certain drugs may be incorporated into liposomes in order to administer them. And in this way, the drugs may be protected from degradation and may not exert general toxicity when introduced into the bloodstream. It's all well and good to have dictionary definitions, But what does that really mean? Because it sounds like a lot of scientific mumbo jumbo. And one of my main purposes is being able to communicate this so that people actually understand it. So if we look at the Encyclopedia Britannica, and you can see right here we have a nice visual of a liposome, and it says that it is phospholipids that can be used to form artificial structures called liposomes, which are double-walled, hollow spheres useful for encapsulating other molecules such as pharmaceutical drugs. Okay, so that's starting to make a little bit more sense now. Well, let's take a look at our actual cell membranes that every cell in our body has. Well, our cell membranes consist of phospholipid molecules. That's a little similar to the liposome, with a hydrophilic head and one or more hydrophobic tails. Okay, and it says that in a water medium, the molecules form a lipid bilayer. And in order to form this lipid bilayer, as you can see from this visual, the heads are turned towards where the water is, because they are hydrophilic. They love water-loving molecules, actually. And then the tails are sheltered inside, away from the water. So in actuality, I think a really good friend of mine and one of my business partners says it best. Christy Clark, it's essentially a fat bubble that you can throw something in and it will get absorbed by your body. I think that's the easiest definition. So, but what I'd like us to take a look at here is comparing what our cell membranes look like and what a liposome looks like. And you can see that both of them consist of at least 2 layers of these phospholipid molecules. And that is what is extremely important when it comes to absorption of nutrients, drugs, whatever you're looking to put in a liposome in your body. And so let's take a look now at the history of liposomes, because liposomes have actually been around for quite a long time. So back in 1965, Alec Bingham was the first person who described the closed system of this bilayer of phospholipids. And believe it or not, liposomes were actually called bangosomes. You can see it's probably named after him. But we call them liposomes now. And then in 1971, Gregory Goriadis, together with who we call the Madam of London, also known as Brenda Ryman, proposed that liposomes could be used as carriers of enzymes or drugs. So as you can see, there's been quite a long history going back many years for liposomes and their usefulness in the medical community. And so I wanted us to look at a few of the industrial applications of liposomes. Liposomes have been used as drug delivery vehicles in medicine. One of the major areas was being able to deliver drugs for chemotherapy, to get targeted drug delivery so that these important drugs were able to withstand the conditions of the acid in our stomach and get through and actually get into the bloodstream where they needed to go to help patients with cancer. They've also been used as adjuvants in vaccinations, and they've been used as signal enhancers or carriers in the medical diagnostics and also analytical biochemistry. Other things that they've been used for are solubilizers for various ingredients, support matrices for ingredients, and one thing that I'm so excited we will be talking about Belisa in another episode, but liposomes have been used in the cosmetic industry for a while now as well to help penetrate the skin and get whatever nutrients that we want into our bodies that way. And also transdermal patches that people wear, those are all essentially liposomal based. Now I'd like us to take a look at the advantages on why you would want to have products that have a liposomal delivery system. One of the major important reasons is the increased bioavailability and absorption that you're going to get when you compare it to other oral forms of supplements. Another major factor, it's a non-invasive way. It avoids people having to be exposed to the pain and discomfort of having to get drugs through an IV. And, a lot of people, I know personally myself, are not a fan of needles. As a child, I would scream anytime anyone in a white coat came near me. I've gotten a lot better now that I've gotten older, but a lot of people are scared of needles. And so you think about, with kids especially, being able to give kids medicine, important nutrients that they can take orally rather than having to go and get it intravenously. Another thing that this will help with is the decrease in the contamination risk as well. What else? Well, let's see. We also, when you encapsulate and protect those nutrients, then they're able to survive the harsh environment of our gastrointestinal tract, our GI tract, so essentially our stomach. Our stomach has stomach acid. That's how we, dissolve our food. And if you try and put drugs in there, a lot of nutrients or drugs get decomposed because of the stomach acid. And so by doing it with a liposomal or liposomal delivery, you're going to increase your oral uptake and absorption. You're going to increase your intracellular delivery. The other thing that's amazing about these products is that they can hold both hydrophilic, which is water-loving, and hydrophobic compounds. So depending upon what type of nutrient you want to give your body, these liposomes are able to carry it for you. These are ideal for those people that swallowing a tablet is not possible. All right. And so they can take something in a liquid form and get it absorbed into their bodies. Having a liposomal delivery also allows for adjustable incremental dosing for children or adults. And a huge thing that, personally with me, single mom, 2 kids, cost effective when you're able to not have to try and, cut a tablet. When you take pills, your pills come in, 50 micrograms or 100 micrograms. When you have something with a liposomal delivery system, you can have 16.2 micrograms. So you can adjust the dosage a lot easier. And so this is going to lead me to talk about the company that I have been involved with now. And the reason I wanted to explain, I want everyone to know when I walk up to people what a liposome is. And that is Viseo. And Viseo's advanced delivery system, which is all based on liposomes, however you want to pronounce it. So I could do my best to explain the delivery system that Viseo uses. However, they've got an amazing video. So I'm going to let you guys watch that now.
Liposomes are double-layered bubbles or spheres comprised of lipids that work wonders when it comes to the advanced delivery and absorption of nutrients. Liposomal protective walls consist of 2 layers of tiny lipids that form a protective sphere around the nutrient. Nutrients encapsulated in liposomes are now delivered in a form that allows them to pass through the harsh environment of the digestive system intact, cross the villus membrane, and enter the bloodstream. From there, the liposome connects to the cell and delivers the nutrient. But the benefit doesn't end there. Because the liposome is made of the same material as the cell wall, it becomes part of the makeup of the cell, refortifying it and allowing for proper regeneration in the future. This is the good news your body has been waiting for.
Thank you so much for joining me on this week's episode of Science with Dr. CK. Don't forget to come back next week so we can get our weekly dose of H2O.